that. Now we have to see some questions about. So we have done. Now we'll see this question today. Motion in a straight line still. An elevator is accelerating upwards, is accelerating upwards. I think నేను కవర్ చేసినట్టున్నాను, but anyway, is accelerating upwards with an acceleration A. With an acceleration A. Okay. If a person inside the elevator throws a particle vertically upwards, if I say vertical upwards with a velocity u, relative to the elevator, time of flight is t is equal to 2u by g plus a. Okay, this equation we can derive, but మీకు ఏంటంటే దీనిలో you have to know something about non-inertial frame of reference. అదేంటనే చెప్తాను, టూకీగా చెప్తాను వాట్ ఈస్ వాట్ అనేది. సపోజ్ దిస్ ఈస్ అన్ ఎలివేటర్ మీన్స్ లిఫ్ట్ అనమాట. సో ఇన్ ద elevator is moving. Suppose elevator is moving up. Okay, now he has thrown one ball or object like this to the top. Now we are observing this from outside. ఓకేనా, ఇది అర్థమవుతుందా కాలేదా కొంచెం చెప్పండి, ప్లీజ్ రెస్పాండ్ ఆల్ ఆఫ్ యూ. ఓకే, వన్ బై వన్. We are observing this elevator is moving up with an acceleration of a upwards. Okay na? And now ఈ బాల్ ఇలా పైకి వేసినప్పుడు what are the forces అనేది మనం చూడాలి. So this situation that when I am seeing from upwards, it is very difficult. ఈ లిఫ్ట్ యొక్క ఫోర్స్ ఏ విధంగా యాక్ట్ చేస్తుంది ఈ బాల్ మీద అనేది కొంచెం డిఫికల్ట్ చేయటం అనేది. ఓకేనా, సో మనం ఏం చేస్తామంటే we will go inside the lift. So when we move inside the lift, this is called accelerating frame of reference. It is called accelerating frame of reference. This is outside. This is called inertial frame of reference. Inertial frame. When I move inside the lift, when I am moving along with the lift, okay, it is called non-inertial. Okay na, clear? When I'm outside the lift, it is called inertial frame. When I go inside the lift, it is called non-inertial frame, because I am moving along with the lift. E part clear? Hello?
Yes, sir.
Okay, now when I go inside the lift, nadi acceleration ye, lift acceleration kuda yene. Okay na? Yeah, I am also accelerating along with the lift, right? Hello? I am also going along with the lift, and I am also accelerating with A along with the lift. Now, ఇటువంటి కండిషన్లో there will be, what we observe is that we will observe a pseudo force downwards. I should say something called pseudo acceleration downwards. A pseudo acceleration exactly మన మూమెంట్ కి ఆపోజిట్ లో ఉంటుంది. అంటే ఇలా ఉంటుంది. ఏ అనే యాక్సలరేషన్ తో ఇలా ఉంటుంది, ప్లస్ ఈ బాల్ మీద జీ అనే యాక్సలరేషన్ కూడా ఉంటుంది డౌన్వర్డ్స్. సో కంప్లీట్ యాక్సలరేషన్ వచ్చేసి జీ ప్లస్ ఏ. ఓకే, నౌ లెట్స్ అప్లై ద ఈక్వేషన్ v స్క్వేర్ మైనస్ u స్క్వేర్ ఈక్వల్ టు 2a. ఎస్, యు నో v స్క్వేర్ దిస్ పార్ట్ ఫైనల్ వెలాసిటీ, ఎందుకంటే ఇది ఒక టాప్ మోస్ట్ పాయింట్కి వెళ్ళి ఆగిపోతుంది. సో v స్క్వేర్ ఇస్ 0. So you have minus u square. Instead of acceleration, ikkada a plus g vastundi. So 2 times of a plus g times, yes, this is what you get. So this is the displacement. Okay, I had to find the time v equal to u plus 80 maybe I had to do. So that's what we do. Okay, we do the equation v equal to u plus 80 and then substitute directly we'll get. So we have to do v is equal to u plus 80. So v is 0 anyway. ఒక పాయింట్ లోకి వెళ్ళి ఆగిపోతుంది కాబట్టి 0 is equal to u. u అంటే అప్వర్డ్స్ ఏ ఉంది, మైనస్ ఆఫ్ g plus a times t. That's it, finished. That's the time of flight. Time of ascent వచ్చింది మనకి. Time of ascent is u by g plus a. Time of ascent is same as time of descent కాబట్టి time of flight వచ్చేసి మీకు 2u by g plus a వస్తుంది. So hope you got the idea. అంటే neglecting the resistance మీకు ఇదే వస్తుంది. Time of flight 2u by g plus a. This is the acceleration. Okay na? Clear? When the lift is moving up. Your voice is not clear. Your voice is not clear. Hello? Is this okay? Your voice is not clear. Time of ascent is equal to time of descent. So time of flight వచ్చేసి sum of these two. Time of ascent plus time of descent, that is 2u by g plus a. So that's what it is. Now we'll go ahead. Next case is that when case number 2. In the above case, if the elevator accelerates down, if the elevator accelerates downwards, accelerates down with an acceleration of a is less than g situation. Okay, Now, how to draw that is, we will go and sit in the non-inertial frame once again. This person is throwing the ball up. Now the acceleration is downwards. Downward acceleration కాబట్టి మనం ఏంటంటే upward ఇస్తాం. Pseudo force upwards ఇస్తాం. So A and this is G. So lift acceleration కి opposite ఇవ్వాలి మీరు. లిఫ్ట్ ఏ సైడ్ యాక్సలరేట్ అవుతుందో దానికి ఆపోజిట్ ఇవ్వాలి మీరు యాక్సలరేషన్. సో నాన్ ఇనర్షియల్ లో ఉన్నప్పుడు. So it is accelerating downwards. So A you give upwards. But the ball will come down, no? So the net acceleration, A net becomes G minus A. So once again apply V is equal to U plus AT. So you get the time of ascent as same thing, same way what we had. 0 is equal to U minus of G minus A times TA. We'll do the time of ascent, that is U by G minus A. That is equal to time of descent. So the time of flight happens to be 2U by G minus A. There's one way of calculating time of flight. There is another way by using S is equal to UT plus half AT square. This also we can use. UT plus half AT square. This also we can use to calculate time of flight, because this is a vector mode of calculation. Vector mode of calculation is this way. So you have acceleration G minus A, and then it moves from here and it completes the same, comes back to the same point. Okay, right? And then our top ki move ayi, it comes back to the same point. So we can substitute that displacement is 0. Displacement 0 chesin tarvata what you get is time of flight. Okay, so you have UTF minus half into G minus A, ఇక్కడ net acceleration, ఇక్కడ A net వచ్చేసి G minus A into TF square is equal to 0. Now the other one is TF, which is manam, when you take it off, U minus half into G minus A times TF, that is equal to 0. So directly you will get the TF as 2U by G minus A. This is another way of solving. The entire problem also you can solve by this way, by making the displacement equal to 0. So this is the way of solving the time of flight. You can make the displacement equal to 0. ఎందుకంటే ఒక పాయింట్కి వెళ్ళి మళ్ళీ it is coming back to the same point, right? So but the thing is, you have to be in the non-inertial frame in order to solve this problem. Please understand this. Inertial frame, it is literally tough, somewhat tough. I'm not saying, but this is the non-inertial frame. When you say it, it's very easy. In the non-inertial frame, what you have to do is, you find the acceleration of the lift, which way it is going. You give the acceleration opposite to that for the ball or whatever the object you have thrown up. That's what you have to remember. Hope I am clear. Is this okay? Clear? These are two methods of solving the same problem. One is vector mode, this is another one is a scalar mode. I solved both. You can do.
Noted, sir.
Clear, good. Now, another question. So, projection from a top of a tower. These are all vector mode problems we can do. Projection from top of a tower. Top of a tower. Projection from top of a tower. So how do we deal with this? So what is this projection from top of a tower? Okay. So this is the tower or a building we have. Okay, ma? So on this building, this building is here. This building is of height h, let us say. This is of height h. And now what we did was the ball is thrown like this upwards. Ball is thrown like this upwards with some velocity u. Okay, with some velocity u. It goes like this. Okay, and it starts falling like this. Okay, goes like this and it will fall like this, almost like we are doing it at the edge of the tower. Okay, so this is the situation what we are talking about. It falls like this to the ground. Okay, now at the same point, when it returns back at the height of the tower, this is u only at this point. Okay, some height it will reach and it will fall down. So the question one is that a body is projected vertically up from the top of a tower, from the top of a tower of height h, with a velocity u, and takes t seconds to reach the ground, then the height of the tower is. So this is what we had to solve. We had to find the height of the tower. It reaches us. So here we go. So h, how to calculate this? So it's done by this way. Simple, Amma. See, what is the displacement ultimately? It is falling from this point to this point. The displacement is from here to here. So your measurement is downwards. Hope you got it. Our measurement is downwards, so it is minus h. This is the initial point, this is the final point. So displacement mode only will solve. Let it travel all these things, no problem. But the displacement is, this is the initial point and this is the final point, so it is minus h, downwards. So minus h is equal to u. U is projected up, so u t minus acceleration is downwards, minus half g t square. Okay, right? So when we are doing this, so when it is projected up at this point, it is like minus g downwards. So this is how you get minus h is equal to ut minus half j square. So this is what you are going to get. So this is So the equation, it seems it is wrong what is given. Yeah, correct only. The minus ut, yeah, yes given. So h is equal to, you will get h is equal to minus ut. If you take the negative signs, you will get minus ut plus half gt square. This is the height of the tower. This from the vector mode, you will get like this. Hope you understood the calculation.
Noted, sir.
U upwards, G is downwards. So this is how you get the calculation. Now, next one. If an object if an object is dropped from a balloon, is dropped from a balloon, raising up with a velocity u, with a velocity u, at a height h, Now the equation of motion relative to earth, it's the same calculation. H is equal to minus ut plus half gt square. Why it is like that is, ball when it is dropping, the dropped object will also have the velocity u, initial velocity upwards. So it's the same as projection from the top. Just now what we solved. Now the third one. Now equation of motion relative to balloon, with respect to balloon, when you sit on the balloon, it doesn't have any velocity, no initial velocity. So h is equal to half gt square. So the thing is, what balloon we are talking about? This gas balloons will be there where you can sit, right? మనం మాట్లాడుతుంది ఆ balloon గురించి. So it's like this one. There will be a cage kind of thing. Fire will be coming up, and this balloon will be tied like this. Okay. Fire will be here, and this balloon will be raising up. Okay. And from this balloon, a person is standing here and he is throwing something down. Okay. He's just dropped this. Okay. Dropped something with the balloon is moving up with the u, and he just dropped the object. So that is the situation we are talking about. So relative to balloon, this is how you get. This is with respect to earth, because with respect to earth, the object is also moving with the velocity u, initial velocity u only. So this is how you get. Noted?
Noted, sir.
The next one, relative to earth, relative to earth, the body moves up and falls. Relative to earth, the body moves up and falls. Relative to balloon, relative to balloon, the body falls vertically downwards. Most important points. అంటే క్వశ్చన్ ఎలా ఉంటుందంటే కింద నుంచి చూసేవాడికి ఇది ఎలా కనిపిస్తుంది, బెలూన్లో ఉన్న వాడికి ఎలా కనిపిస్తుంది, రెండూ అడుగుతారు. కింద నుంచి చూసేవాడికి ఎట్లా ఉంటుందంటే బాల్ ఇలా పైకి వెళ్ళి కింద పడినట్టు కనిపిస్తుంది, బెలూన్ ఉన్న వాడికి స్ట్రైట్ డ్రాప్ చేసినట్టే ఉంటుంది. సో దట్స్ హౌ యూ హ్యాడ్ టు రైట్. దీని బేస్ మీద క్వశ్చన్స్ చాలాసార్లు అడిగారు ఎర్లియర్. So noted?
Noted, sir.
Okay. Now the next one. Distance between the object and balloon. Distance between the object and balloon. ఇది ట్రై చేయండి మీరు. ఆఫ్టర్ ఎ టైమ్ t, ఆఫ్టర్ a time, after a time, after a time t, after a time t, after the drop, after drop. అంటే ఏం చేస్తున్నాం అంటే ఇక్కడ బెలూన్ ఉంది కదా, ఫ్రమ్ దిస్ బెలూన్ వీ హ్యావ్ డ్రాప్డ్ వన్ ఆబ్జెక్ట్, ఇలా డౌన్వర్డ్స్ డ్రాప్ చేసాం. బెలూన్ వచ్చేసి ఇలా పైకి వెళ్తుంటుంది, ఆబ్జెక్ట్ వచ్చేసి కిందకి ఇలా వెళ్తుంటుంది. వాట్ విల్ బీ దిస్ ఎక్స్ డిస్టెన్స్? ఓకే, ఇది క్వశ్చన్. నేను ఒక హింట్ ఇచ్చేస్తాను సో దట్ యూ విల్ అండర్స్టాండ్. సో హియర్ with what velocity it will move. Okay, ఒకసారి ఆలోచిద్దాం. సో it has some initial velocity u కదా, it has some initial velocity u, but here what we can do is దీన్ని మనం స్టేషనరీ చేద్దాం. దీన్ని మనం స్టేషనరీ చేయటం అంటే we will fix this below. ఈ బెలూన్ ఫిక్స్ చేసినప్పుడు అంటే ఇది మూవ్ అవ్వట్లేదు అనుకున్నామంటే దిస్ వెలాసిటీ షుడ్ బి గివెన్ సమ్వేర్. దీని వచ్చేసి ఈ ఆబ్జెక్ట్గా ఇచ్చేద్దాం. దిస్ బాల్ విల్ టేక్ దట్ వెలాసిటీ బట్ ఇన్ ఆపోజిట్ డైరెక్షన్. దీనే రిలేటివ్ వెలాసిటీ అంటారు. సో దీనికి డౌన్వర్డ్స్ యూ ఇచ్చేద్దాం. సో హియర్ ఇట్ విల్ బి హ్యావింగ్ సర్టెన్ వెలాసిటీ v ఆఫ్టర్ ఎ టైమ్ ఆఫ్ t. v will be like you can write u plus at. So u is there, in fact u plus gt type. V is equal to u plus gt after a time of t. And now you know this v is equal to u plus gt downwards. And now you can use v square minus u square equal to 2as to calculate this. Okay, so here a is g because we are moving downwards itself. So దీన్ని బట్టి మీరు క్యాలిక్యులేట్ చేయొచ్చు. సో s is some x, what is the distance? So plug in that, so you get x happens to be or you can use directly ut plus half gt square. This is straight ut plus half gt square you can use. So directly you will get this answer. Ut plus half gt square directly you will get. So this will be the velocity initial that will be given down. So ut plus half gt square, that will be the value of x. I hope it is clear.
Noted, sir.
Okay. Now, if a body is projected vertically up with a velocity u, with a velocity u, the body is projected vertically up with a velocity u from a tower and it reaches the ground and reaches the ground with a velocity nu, with a velocity nu, n into u, n times the initial velocity, it will reach the ground. Then the height of the tower is, tower is h is equal to u square by 2g into n square minus 1. This is what we have to prove. So I'll tell you once again the vector mode of calculation. So here మనం ఏం చేస్తున్నామంటే this is the tower. Okay, once noted, please note of the question. I will tell you, we need some space to solve this.
Noted, sir.
Noted. Good. So let us see, this tower is there. And again, we'll solve this by vector mode so that you will understand this, how to handle the vector mode. From this tower, we have the height of h. The tower is of height h. Now, which way the object is falling, that's what you have to see. Now, this body is projected upwards, doesn't matter. It is projected upwards. And from this point to this point, it is falling, right? Finally, ultimately, what is the displacement? This is the initial point, and this is the final point. This displacement is measured downwards. Antena? This is measured downwards. Ante, this is initial point, top of the tower nunchi project chesaru, bottom ku vachindi, it is measured downwards. Clear? So the displacement S happens to be minus h. Put it first. Now, it took some time t. Okay, some time t vachese time vachese vachindi mata. This took some time t to fall down. But what is the initial velocity of projection? Upwards. U is plus u upwards. Okay. But acceleration due to gravity, A is always minus g. Don't have to worry about it. A is always minus g. Fine. Now, what else we need? The final velocity. Final velocity, you see, that is downwards. Final velocity is nu. that is plus minus nu we have to put because it is downwards. V final is minus nu downwards. Okay. Final. Initial velocity is upwards. Vf is nu downwards. With this final velocity, it is hitting the ground. Now let's use the equation v square minus u square equal to 2as. So v final square, that is minus nu whole square minus u square is equal to minus 2g. S is nothing but h. 2gh. Right. So it is n square u square minus u square
Sir,
is equal to, yes, yeah.
sir, minus h, sir. S is equals to, you tell minus h, sir.
I forgot. Here minus h also we have to put. Correct. Yes, correct. So G is minus, A is minus G, S is equal to minus H. Yes, S is equal to minus H, I forgot. Good, thank you. So this becomes 2GH, right? So n square if I take common, u square if I take common, I'll get n square minus 1 into u square, that is equal to 2GH, right? So H is equal to, I got the answer, n square minus 1 into u square divided by 2G. Yeah, very good. That is substitution. When you do the substitution, ఇక్కడ substitution చెప్తాను. 2a బదులు minus g, s బదులు minus h. I forgot to put that. So it's like this you have to put. So you will get 2gh. I hope clear.
Noted, sir.
This is called vector mode of solving the problem. Very fast గా అయిపోతాయి ప్రాబ్లమ్స్ అన్ని వెక్టర్ మోడ్ లో సాల్వ్ చేస్తే మనం. Almost we are at the end of the chapter అనమాట. ఇంకో 2-3 questions ఉన్నాయి యాక్చువల్గా. Anyway, we will see tomorrow that we will finish off this chapter. Next, 5th one. One more question. A particle is projected. A particle is projected. We may get a timeout now. Vertically up. Vertically up. From top of a tower. From top of a tower. Takes t1 seconds. Takes t1 seconds to reach the ground. Reach the ground. Takes t1 seconds to reach the ground.